Hi. In this session, this is the fourth session. In the first three sessions, we have seen how to solve a linear ordinary differential equation with constant coefficients. Okay, and the solution contains a complementary function and particular integral, and different methods of finding particular integral were also discussed. And the next topic is a different standard linear differential equation, and that is Cauchy's equation. Okay, and this one is the coefficient may not be constant. Okay, but the coefficient cannot be any function of x. The coefficient of y is a constant. The coefficient of dy by dx is some constant times x, and the coefficient of the second order d square y by dx square is x square. Okay, this is the general form of a second order Cauchy's equation. This can be extended up to an nth order differential equation. Okay, so how to solve such an equation? So when you see a differential equation, to verify that it's a Cauchy's equation, just look at the coefficients of the differentials. Okay, that means the coefficient of y should be a constant, coefficient of dy by dx should be x, some constant times x, and coefficient of d square y by dx squared should be x squared. And on the right side we have any function of x. So how this can be solved? So the method is, we give a substitution for this problem. Okay, we give a substitution for x actually. Then this function is reduced to a linear ordinary differential equation with constant coefficients. Then in any of the previous methods can be applied and we can solve that. Okay, so that substitution is important. So this is a substitution. Put x is equal to e to the power t. Okay, or from this one you can write t is equal to log x. Okay, and if we denote d as d by dt, that means our differential equation now is going to be changed, and the independent variable is going to be t. Instead of x, we are going to change that with respect to t. Okay, then this time x times dy by dx, okay, will be changed to dy, and d is d by dt, that means dy by dt. Okay, and x square d square y by dx square will be changed as d times d minus 1 times y. And we can extend this one, like if there is times like x cube d cube y by dx cube, then this is going to be d minus 1 d minus 2 times y. Okay, so this is a substitution and the corresponding changes. Okay, so the derivation part I'm not going to discuss here. Okay, so you substitute all these values here. For example, x dy by dx is going to be changed as dy. So this is going to be some dy, and this is going to be some d times d minus 1 of y. When you simplify, this becomes a linear ordinary differential equation with constant coefficients, like the one we have seen before. And you can solve that using any of the methods we have studied. That's it. Okay, so so these are the things to be remembered, and when you do a problem, in all the questions you have to show these substitutions. Okay, right, now let's see some examples. Okay, this is the first example. X square d square y by dx square minus x dy by dx plus y is equal to log x. And note that this is a Cauchy's equation, right? So first you have to substitute like this. You put e to the power t is equal to x, and then t is equal to log x. Next dy by dx is going to be dy, where d is dy dt. X square dy by dx square is d times d minus 1y. And substitute those values here. Okay, so x square d square y by dx square is replaced by d times d minus 1y, and this one is replaced by dy plus y is equal to, and log x is t. Okay, when you simplify that, d square minus d, this is minus d, plus 1, you take out y is equal to t, and when you simplify, this is what you will get. Now this one is a linear differential equation with constant coefficients. Okay, so the solution of this one definitely contains the complementary function and particular integral. So the complementary function, first you write the auxiliary equation as m square minus 2m plus 1 is equal to 0, and m is going to be 1 1. Okay, and yc is equal to, when you write the complementary function, make sure that it should be in terms of t, because we have changed the problem from x to t. The independent variable now is t, not x. So yc is c1 e to the power t plus c2 t times e to the power t. This is the complementary function. Okay, and the particular integral. To find the particular integral, yp is equal to t by, actually you can write this as d minus 1 the whole square, right? D minus 1 the whole square. Or you can write this as t by 1 minus d the whole square. You know, it's a square 1. I mean, this is the whole square. So even if we change d and 1, that won't make any difference. Okay, or you can write this as 1 minus d the whole raised to minus 2 of t. And this one has an expansion. The expansion is 1 plus 2d plus 3d square plus etc. of t. Okay, and this one is an infinite series. So this one has a degree 1, so it's enough to consider only the first 2 times. So 1 times t is t, plus 2 times derivative of t is just 1, and the second derivative onwards will be 0, right? So the particular integral is t plus 2. Okay, and this is the complementary function, and this is a particular integral. When you write the final answer, y is equal to yc plus yp. Okay, and this is yc and this is yp. And what is e to the power t? E to the power t is actually x. So you substitute that, c1 e to the power t is x plus c2, t is log x, and e to the power t is x. So this one will be x log x plus, and t is log x plus 2. This is going to be the solution. That means at last your answer will be in terms of t, but using these two relations you can change all t in terms of x. Okay, so the final answer should be in terms of x, and this is the final answer. All right. Okay, one more problem. Okay, this is the second problem. X square d square y by dx square minus 2x dy by dx minus 4y is equal to x square plus 2 log x. Okay, so as in the previous problem, we do the same substitution here. So x square d square y by dx square is replaced by d times d minus 1y, and this one x dy by dx by dy, and x square becomes e to the power 2t, log x is t, so it will be 2t. You simplify this, d square minus d minus 2d minus 4. Okay, and then it will be d square minus 3d minus 4y is equal to this one. And now this one is a linear differential equation with constant coefficients. Now for solving this one, we have to find the complementary function. So write the auxiliary equation. Find two numbers whose product is minus 4 and sum is minus 3. So those are minus 4 and 1. And these are the values then, 4 and minus 1. So the solution is c1 e to the power 4t plus e2 e to the power minus t. Okay. And on the right side we have two functions, e to the power 2t and 2t. So find the particular integral of these two separately. So first find the particular integral of e to the power 2t. So we call that as yp1. So e to the power 2t divided by this function of t. Then replace d by 2. Then you will get 4 minus 6 minus 4. 4 will be cancelled and this is what you will get, e to the power 2t by minus 6. And the second particular integral is of 2t. So 2t by this one, and this is a polynomial. So we have to use that standard equation. So take out minus 4 from here and you will get 1 plus 3d minus d square by 4. And write this in the numerator. So 1 plus x the whole raised to minus 1, 2t. When expand you will get, actually it's enough to write only one time. 1 minus this time. 1 minus this time. So 1 times 2t is 2t. Then 3d over 4. That means derivative of this one, 2t, is just 2. 2. Okay. So you'll get minus 3 by 4 of 2. And that is what you will get. Okay. So when you write the final answer, y is equal to c1 e to the power 4t plus c2 e to the power minus t plus the first particular integral e to the power 2t by minus 6 plus then the second particular integral minus 1 by 4 times 2t minus 3 by 2. Okay. Now replace the functions of t by the functions of x. E to the power t is x. So this is c1 e to the power t is x raised to 4. So this is x to the power 4 plus c2. E to the power t is x. X raised to minus 1 is just 1 by x plus e to the power 2t is x square by minus 6 minus 1 by 4 times 2t is log x minus 3 by 2. This is the final answer in terms of x. Alright. So that's all about the Cauchy's differential equation. Okay.